Page 16 of probability. What does the addition law say? Oh, we just did that on the previous page. The addition law says that if you have, and we'll draw a Venn diagram here to show it, if you want this region, which is A union B, then it's basically like adding this region with this region and then removing the double counted part here. So basically what you do is you say, oh, it would be the probability of A, which is the red part, plus the probability of B, which is the blue part, and then I would subtract out the double counted part, which is the intersection of the two. That's what the addition law says. What is the addition law when A and B are mutually exclusive? Well, when A and B are mutually exclusive, the purple middle part doesn't exist, right? Because the two circles don't overlap. So then it's just probability of A plus the probability of B, and there's no need to subtract out anything because they don't overlap. Okay. Given two events, A and B, the conditional probability of A given B is the probability that A occurs given that B has already occurred. The conditional probability is written as A vertical line B and is read as A given B, just like it's written here. If A and B are events, then probability of A given B is equal to the probability of A intersect B over the probability of B. It follows that the probability of A intersect B is equal to probability of A given B. And now we're just going to use algebra. So do you see how if you have probability of A intersect B and you want it by itself, then you can isolate it by multiplying both sides by probability of B. So you could actually say, hey, the probability of A intersect B is equal to the probability of A given B times the probability of B. So I can put probability of B here. Okay? And it works the other way too. I could instead of writing, do you see how these are all A's, right? And then these are all B's. What if I just switched all the browns to A and I switched all the purples to B? It's the same thing, right? I just renamed A and renamed B A and I renamed A B. I could make a different rule, which is also true. A intersect B remains the same because A intersect B is the same thing as B intersect A. Now that I have a new rule with A's and B's inverted, I can also use algebra, and then I could take this part here, probability of A, multiply both sides by probability of A, and then I would get the probability of A intersect B is also equal to the probability of B given A times the probability of A. So I've just derived two different rules, and actually they pretty much say the same thing. Okay, number one. If the probability of A is 0.4 and the probability of A union B is 0.9, then the probability of A intersect B is 0.1. Find probability of B. So now we can just use, one of these formulas or the addition rule to figure it out. Okay? So how about we use the addition rule? So you can use a Venn diagram too if you like Venn diagrams. So if you have A and B, the probability of A is the whole thing is going to be 0.4. And then the union is 0.9, so the whole thing is 0.9. And then the A intersect B part, which is the middle part, is 0.1. And B, we don't know. But you can kind of see from this diagram, the whole thing is 0.9. You subtract out the middle, or wait a second, the whole thing is 0.9. The A part is 0.4, but you know that the fish part is 0.1, so the bit apple part is going to be 0.3, right? So the total's up to 0.4. And then the whole thing, A and B together, is 0.9, so that means you subtract out 0.3 and 0.1, and you're left with 0.5. So the bit apple part of B is 0.5. So we can figure it out with the Venn diagram. The other way you can figure it out with is you use the, what do you call it? The addition rule. You know the addition rule. And then you just use algebra. You just use the addition rule. A union B is equal to the probability of A plus probability of B minus the fish part that's in the middle. You know, I say the fish part because it looks like a fish. Okay. Probability of A is 0.4. Probability of B is, we don't know. Probability of A intersect B is 0.1. And the probability of A union B is 0.9. So we could do algebra, and then we add or subtract 0.4 from both sides. We get 0.5 on the right. We add 0.1 to both sides. We get, let's see, so 0.5 or 0.9 minus 0.4 plus 0.1. I got 0.6. Hey, that's weird. That's weird. Oh, I get it. Yeah, that's right. Because, like, look at that. I figured out that, like, the bit alpha part of B is 0.5, but the whole B is 0.6, right? Okay. Yeah, so this, what I wrote here is wrong, right? Sorry about that. All right, A and B are mutually exclusive events. Probability of B is 0.45. Probability of A union B is 0.8. Find the probability of A. Okay, so remember, the addition rule for mutually exclusive events is probability of A union B is equal to the probability of A plus the probability of B. So probability of A union B is 0.8. Probability of A is, we don't know. Probability of B is 0.45. And so X is actually going to be 0.8 minus 0.45, which is 0.35. Is that right? So, yeah, so probability of A is 0.35. So actually using the formula is quite a bit easier than like drawing the Venn diagram, right? In a group of 40 boys, 23 have dark hair, 18 have brown eyes, and 26 have dark hair and brown eyes. One of the boys selected at random. Determine the probability that he has dark. Okay, so I've drawn a Venn diagram with D for dark hair and B for brown eyes. And I'm going to mark the quantities here. So like here we got 40 total. And the D part is dark hair at 23. The B part, which is brown eyes, is 18. And 26 have dark hair and brown eyes, or both. So that would be 26 here. Okay. And then now we can use this and the addition formula to figure out how many inside the fish section. Okay. So we have probability of D union B is equal to the probability of D plus the probability of B minus the probability of D intersect B. So the probability of D union B we know is 26 divided by 40. The probability of D we know is 23 divided by 40. Probability of B is 18 divided by 40. And the probability of D intersect B is, oh, we don't know. Okay? So now we can just use algebra and figure out what X is. X is equal to 23 plus 18, 41 divided by 40, minus 26 divided by 40. 41 minus 26 is 15 divided by 40. Okay, that is equal to the probability of D intersect B. D intersect B. Okay. D intersect B is dark hair and brown eyes. So we just figured out that this is 15 divided by 40. What about dark hair but not brown eyes? And now I think we can start filling in some numbers here, and it's going to help us figure out everything. So, like, we know that the fish shape is going to have 15. And we know that the bit apple shape of D is going to be 23 minus 15, which is 8. The bit apple shape of B is 18 minus 15, which is 3. And let's check to make sure that those add up to 26. 8 plus 3 is 11. Plus 15 is 26. Good. And then 40 minus 26 would be the region outside the two circles, which would be 14. Okay, so now we can figure out everything. So dark hair but not brown eyes. Dark hair but not brown eyes. So that would be dark hair but not brown eyes. It would be 8, right? 8/40. Okay. What about neither dark hair nor brown eyes? That means neither circle, which would be 14 out of 40. Then brown eyes, given that he has dark hair. So, given that. So that means it would be the probability, it's easier to use a formula for these, probability of brown eyes given that he has dark hair. So that would be the probability that brown eyes intersect with dark hair, divided by the probability of dark hair. If you go back and look at the formula, that's what it looks like, okay? And I don't have enough room to write it, I don't think. So we're going to have to write it down here. Probability of B intersect with D, remember, is 15 divided by 40. And then the probability of D is 8 plus 15, 23 divided by 40. So if we were going to do algebra and simplify, or not even algebra, this would be like elementary school math. The 40s cancel each other out. You end up with 15 divided by 23 would be the answer for D, brown eyes, given that he has brown hair. Okay?